Lesson 13. Advanced Arduino Programming, Part 2. Contents. The topics covered in this lesson are arrays, functions. The task or activity for this lesson includes arrays. An array is a collection of one type of variables that are accessed with an index number. Declaring an array. The syntax for declaring an array is data_type array_name, size, equals value. Value and size may or may not be given at declaration. Examples are as shown. In first example, you can see that you can declare an array without initializing it with values. In second example, we declare an array without explicitly choosing a size but initializing values. The compiler counts the elements and creates an array of the appropriate size. You can both initialize and size your array. Note that when declaring an array of type char, one more element than your characters in the list is required, to hold the required null character at the end of the character array. Here in the third example, we can see hello consists of 5 characters but is declared as 6-character array, to hold last character null. Arrays in Arduino are zero-indexed, that is, array elements numbering starts from 0. Array elements can be accessed with index as follows. In the example, value of C is 6 since third element is at index 2. We can assign a value to an array as follows. 8 will be added at the index position 3, that is, after 6, which is the fourth position in the array. Activity 1. Write a program to create an array and display all elements on the serial monitor. Create an array of size 6 with integers and display elements at index 2 and 4. Solution for the first question in Activity 1. The code is as follows. The output may vary depending on the array elements you have initialized. Solution for the second question in Activity 1. The code is as follows. The output may vary depending on the array elements you have initialized. Functions. What is a function? A function is a block of code either built in, or written by the user, that allows structuring the code into one or more segments, to perform individual tasks. Types of functions. Predefined functions, built-in functions available in Arduino environment, such as print lane, pin mode, analog read. User-defined functions. Functions written by the programmers to run a specific task. Structure of a function. The structure of a function takes the form as shown on the screen. It contains 5 main parameters: namels, return type, the data type of the value being returned by the function. If there is no return value, void can be used. Function name, the name of the function. It is user-defined. It should not start with a digit but can contain letter, number or an underscore. Predefined function names cannot be used. Parameters, the values being passed to the function. These are used inside the code. Declarations, declaring the variables which will be used inside the function. Statements, the code written for a specific task to be performed. Let us see an example. The return type of this function block is integer. The function name of this function block is my add func. The parameters of this function block are integer variables a and b. The declaration of this function block is integer variable sum. The statements of this function block are sum equals a plus b. Return sum. Types of user-defined functions. A function can be called, that is, it can be invoked anywhere in the code, taking the name, at any required point of time. Function with no parameter. A function block which returns no parameter to the main block when called for. An example of this type is as shown. The hello function prints onto the monitor but returns no value to the main loop. The print statement in the main loop executes after the hello function call is executed. We can see in the output. Function with one parameter. A function call which passes one parameter to the user-defined function, when being called for. An example of this type is as shown. The hello function passes 4, from the main loop, making the hello function execute the for loop within it 4 times to print onto the monitor. The print statement in the main loop executes after the hello function call is executed. We can see in the output. Activity 2. Write a program to display all even numbers from 1 to n where n is the parameter to be sent, where n equals 100 is the parameter being passed in the function call. Activity 2. Solution. The code for printing the even numbers from 1 to 100 is as follows. Function with two-parameter. A function call which passes two parameters to the user-defined function, when being called for. An example of this type is as shown. The hello function passes 5 and 2000, from the main loop, making the hello function execute the for loop within it 5 times to print onto the monitor with delay time as 2000. The print statement in the main loop executes after the hello function call is executed. We can see in the output. Function with a return parameter. A user-defined function call which returns one parameter to the main function, when called for. An example of this type is as shown. The adder function passes 20 and 50, from the main loop. The adder function executes the block of codes within and returns the variable cc to the main loop, which is stored in the variable c. The print statement in the main loop executes by printing the c value received in dec equals decimal format. We can see in the output. Function with no return parameter. A user-defined function call which returns no parameter to the main function, when called for. An example of this type is as shown. The variables x and y globally so that they can be accessed anywhere in the file. Initially the main loop prints the values of x and y. The swap function is called in the main loop. It executes the block of codes which swaps the x and y values. Then the control is returned to the main loop. The print statements later in the main loop print the swapped values of x and y. We can see no values being passed to or returned by the function. We can see in the output. Activity. Advanced programming exercise. Activity 3. Motor direction control using functions. Write a program to make the robot's wheels rotate clockwise and rotate anti-clockwise using functions. Which rotation makes the robot move forward? Which rotation makes the robot move backward? Activity 3. Solution. Remember, connect a DC motor with L293 DIC, like you have previously done. The code for the activity is as follows. Setup function. Loop function. Function definition to move the wheels of the robot clockwise and counterclockwise. Here, we can see the Vex Clawbot moving forward. Here, we can see the Vex Clawbot moving backward. Here, we can see the Vex Clawbot moving at full speed. Let us see how VexClobot is used for activities. Thank you.